All right, folks, let's take a look at our video for the review of Chapter 10. So this is really a grab bag of a bunch of different ideas. So let's get into it. Mostly it deals with not just exponents, but radicals in general. Let's see. What we have here is the nth root of a, written with this radical, nth radical of a, is the number that when raised to the nth power is equal to a. So the square root of 81 is 9 because, first of all, when we actually write the square root, we don't write the power. So maybe some of you aren't used to seeing it there. That should be a second power radical. And what that means is when we raise 9 to the second power, we get 81. We're looking for the fifth root of 32 in the next one. So that fifth root means that we're looking for a number such that when we multiply it by itself 5 times, we get 32. And that number turns out to be 2 because 2 to the fifth power is 32. So those are some common examples of simplifying radicals as perfect powers of numbers. So some properties of radicals are the following property. The nth root of a times the nth root of b is equal to the nth root of a times b. And the same is true for their ratio. So what I want to say here is, warning, the nth root of a plus b is not the nth root of a plus the nth root of b. Really what's going on is both of these rules are specific versions of this rule that says when you have two things multiplied together raised to the same power, you get those individual factors raised to the same power. So these are versions of this exponential rule. Okay, and we hopefully by now we know things like a plus b squared is not equal to a squared plus b squared. So it only works with multiplication and division, not addition and subtraction. Okay. We've got some rules here for simplifying radicals. All perfect nth powers are taken out of the radical. Step number 1, I guess. 2, no fractions appear in the radical. And no radicals appear in the denominator. So this is typically called rationalization, or rationalize the denominator. So let's take a look at some examples here. This first example is just a matter of using the property that says the square root of 3x times the square root of 7, since these are both the same radical power, radical 2, must be the same n value to combine these. We have that this is the square root of 3x times 7y. And we can simplify that to just be the square root of 21xy. And that is our simplified version of this radical. Now, here we're talking about simplifying the square root of 20x cubed. So how should this be done? Well, what we should do is, since this is actually a square root, and this rule above says pull out all perfect nth powers, we're talking about pulling out all perfect second powers, or all perfect squares. So what we need to do is we need to take 20x cubed and we need to factor it as best we can. This is 4 times 5 times x cubed, which I'll write as 2 times 2 times 5 times x times x times x. And so what we have here are pairs of factors. Because this is a square root, we want these to occur in pairs of factors. If it was a cube root, we'd want them to occur in triplets, and a fourth root in quadruplets, and so on and so forth. So what this means is the square root of 20x cubed is equal to the square root of 2 times 2 times 5 times x times x times x, which is the square root of 2 times 2 times the square root of 5 times the square root of x times x times the square root of x. And what I'm doing is I'm just breaking this up according to these paired groupings, because what that's going to allow me to do is rewrite that as the square root of 4 times the square root of 5, the square root of x squared, and the square root of x, which will be 2 times the square root of 5. This one I could simplify, and you'll notice that my pair of 2's underneath the square radical became a single 2 outside of the radical, and my pair of x's underneath the radical became a single x power outside of the radical. That's how that simplifies. And then we're left with the square root of x. So I can regroup these as 2 and x outside, and then I have a 5 under the radical and an x under the radical, which I can rewrite one more time as 2x square root of 5x. So the idea is to liberate whatever you can out of the radicals, and these are the values that eventually I pulled out of the radical, and everything else was left. Okay. Now we're going to do a little bit of arithmetic. 3 square root of 18 minus 4 square root of 32. Well, as of right now, this is like 3x minus 4y. These are not like terms yet, so we cannot subtract yet. We'd like it to be of the form something like 3x minus 4x. Once these are like terms, we can simplify. So let's take a look at that. The square root of 18 is the square root of 9 times 2, which is the square root of 9 times the square root of 2, which is a 3 root 2 because the square root of 9 is 3. And the square root of 32 is the square root of 16 times 2, which is the square root of 16 times the square root of 2, which is 4 root 2. So what was 3 root 18 minus 4 root 32 becomes 3 times 3 root 2 minus 4 times 4 root 2. And when we simplify this, we get 9 root 2's minus 16 root 2's. And now they are, in fact, like terms. So now they are like terms. So that's 9 root 2's minus 16 root 2's gives us negative 7 root 2's. And that is our final answer here.